Hello again. Today we're going to be talking about how to remove discontinuities, if that's even possible, from functions that have discontinuities. So let's get started. We have an example here. F of x is a piecewise function. We've got a rational function up in the numerator where x is not equal to 2, which makes sense because there is an x minus 2 in the denominator. We need to find the value of k so that at x equals 2, if the y value is k, the function is going to be continuous for all x's. So let's do that. The first thing we need to do is we need to set the limit equal to the function value. If that's true, if the function value exists and the limit exists and they're equal to each other, then the function is going to be continuous at x equals 2. So the limit, I'm going to take the limit of that fractional part there and set it equal to the function value at 2, which is equal to k. So let's work on that limit for a little bit. The numerator of that fraction can be factored into x minus 2 times x minus 1, and all of that is over x minus 2. Now remember, I'm looking at x's that are near x equals 2, not at x equals 2. So those x minus 2's are not actually zeros, they're just really, really close. I can divide those out and get that x minus 1 is, that's going to behave a lot like x minus 1. Everywhere except at x equals 2. So I'm just going to write it as x minus 1, set that equal to k. So now I'm ready to substitute in 2 for my x into that expression. And when I do, I get 2 minus 1, which is 1. So k would have to equal 1 in order for that function to be continuous at x equals 2. Okay, let's look at a different example. Now I've got b as my parameter. So there's a piecewise function again with two pieces. One of them exists for x's that are less than or equal to 2, and one piece exists for x's that are greater than 2. We need to make sure that the function is continuous for all x's. So in this case, because I have a left-hand limit and a right-hand limit that are different, I'm going to set those equal to each other. So I'm going to set the top piece equal to the bottom piece. And when I do that, I get the limit as x approaches 2 from the left of b minus x squared is going to equal the limit as x approaches 2 from the right of x minus 5 over b. In both cases, I can substitute 2 in for x without creating some kind of an error like something that's undefined or something that is indeterminate. So when I do that, I get b minus 4 equals 2 minus 5 over b. If I cross multiply, I'm going to get b squared minus 4b plus 3 equals 0. That's a quadratic, which I can factor and solve, and I would get that b equals 1 or 3. So either one of those values of b is going to make the function continuous. So that's just solving for parameters to make sure that functions are continuous. If you have any questions about that, please let me know, and I will see you tomorrow.